Hi everyone. In the last week's session, we talked about isolation in the context of databases. We also discussed about different transaction anomalies, different isolation levels, and did a deep dive on serializable isolation, which is the default isolation level in CockroachDB. And we also did a cool demo. So if you have not seen that video, the link is in the description. Today's video will be focusing on read committed isolation, right? And also talking about an exciting new release in CockroachDB, which is 23.2. So, what happens in read committed isolation? So, in read committed mode, every query will see the changes which have already been committed by some other transactions. So, in other words, if you run a select query, say it returns a particular set of results, and you run the same select query again in the same transaction, there is a possibility that you will see different results, right? Because some other transaction might have committed some data. So what are the use cases for this? So if you have specific use cases where occasional inconsistencies are okay, right? You can manage with those occasional inconsistency, but you are more concerned about high concurrency. So in such cases, this read committed isolation makes more sense. So we already talked about CockroachDB and its default isolation level, which is the highest, strongest ANSI transaction isolation level, which is serializable, doesn't permit any concurrency anomalies. Now, as part of 23.2 in CockroachDB, we also support read committed as one of the supported transaction isolation levels. By default, it is still serializable, but this is one of the options which you can set at a cluster level, session level, or transaction level. So this feature is in preview right now. So we talked about different transaction anomalies in the last video: dirty write, dirty read, lost updates, non-repeatable read, phantom read, read skew, write skew, and so on. So with read committed isolation, there's still possibility of these anomalies: the lost updates, non-repeatable read, phantom read, read skew, and write skew. These anomalies can occur. Say for a specific use case, you have set read committed as your isolation level. Now still, if you want to make sure that you reduce the some of these transaction anomalies for critical reads and writes, for that purpose we have these locking reads. So you have two options here: select for update and select for share. So in case of select for update, you can obtain an exclusive lock on each qualifying row, blocking any concurrent writes and locking reads on the row. What it means: so say you have a row, right? So you have transaction 1 which can do a select for update. So you are selecting that row for update. You are reading the value of that and you are locking the row for an update. And at the same time, if a transaction T2 comes and it tries to do the same thing, that will be blocked because that row is locked. There is an exclusive lock on that row. Now say there is a transaction T3 which tries to update that row. That is not possible because that row is locked. But there can be a non-locking read happening on that row. That is quite possible. The next one is select for share. So in case of select for share, a transaction can obtain a shared lock on each qualifying row. So blocking concurrent writes and exclusive locking reads on the row. So in this case, multiple transactions can hold a shared lock on the row. For instance, this is the row. There is a transaction 1 which does select for share. And there is one more transaction T2 which also does select for share. Both of these can acquire that lock in parallel. Now say there is one more transaction T3 which tries to update this row at the same time. That is blocked because there is a lock on this, and it will make sure that both of these transaction T1 and T2 are reading the latest copy of data, and while they are reading that, there is no update happening. So with these two, you can still reduce a lot of these transaction concurrency anomalies. But with these, you can't get rid of phantom reads because it is all about inserting a new row, right? So here you are locking a specific row. There is still a possibility of new row being inserted which satisfies a particular query condition. So in what use cases again? in CockroachDB's perspective, what use cases you can go for read committed, right? So your application needs to maintain a high workload concurrency, minimal transaction retries, right? But they're okay with some of the concurrency anomalies. In such cases, it might be a good option to try. Now, you might be already running on a legacy relational database, right, with read committed isolation, and you want to migrate to CockroachDB for all the great features of CockroachDB. In that case, you don't want to do a lot of application changes and you are happy with the read committed isolation which is already there. So you can use this isolation level. That will make the migration much easier. Now let's jump on a demo. Right? Let's take the same use case as what we took in the previous video. Right? So a hospital which has an application for doctors to manage their on-call shifts, and the hospital has a rule that at least one doctor should be available at any given time, and two doctors are on call for a particular shift, and both of them try to request for a leave. Right? And then we saw that in read committed they could do that, but in serializable they couldn't. Right? So in this particular demo, we'll see that how can we run this with read committed isolation level in CockroachDB, right? And how can we use exclusive locks? I talked about locking reads to strengthen the isolation of read committed transactions. So I have already added doctors table, created the doctors table and schedules table and added some data into it. So now the first and foremost thing to do is to enable the read committed isolation level at this session level, right? So I'm just saying set cluster setting and enable this read committed isolation is true. I've done this here, and then I'm trying to do same thing here, right? I've done it for both the sessions. Now I'll make sure that at least one doctor is available each day of the week. So I'm executing this query and trying to see if at least one doctor is available. You can see on each day there are two doctors available. So let's begin the transaction one now. So I have begin the transaction one, and you can see specified that isolation level as read committed. So now in transaction one, I'm doing select start from schedules, right, where day is 5th December 2023. But you can see here I'm doing select for update. That means takes an exclusive lock on that row. So we use order by here just to make sure the locking occurs in a specific order. So this prevents potential deadlock with another locking read on the same rows, which can cause the transaction to abort. This is more of a best practice. So I have done this. Okay, you can see that on that day there are two doctors available. Now in the another session, I'll start transaction 2. The transaction is started. I'll do the exact same thing here. Select start from schedules again for update on the same day. You can see this is blocked. This is not going forward because there is already a lock on that. So there is no other locking read which can happen on that row. Now in transaction 1, I'm going to update. So you can see update schedules set on call on call is false for that particular doctor, Dr. ID 1. So you can see update is done here. Now I'm going to commit this transaction. Transaction is committed. So once the transaction is committed, you can go and see here in session 2. So we'll see the values. That for Dr. 1, the on call is false because that is committed now and the lock is released. So in this, you already know now that there is only one doctor on call on that particular day. So you don't go ahead and accept the leave application for Dr. 2. So we'll go and say rollback. So with this, we have used read committed isolation level, but on top of that, we have used select for update to make sure that that row is locked and a parallel transaction can't update that, or a locking read parallelly can't happen on that particular row. So this is about read committed isolation in CockroachDB. Thank you.